Hi everyone, this is a tutorial from dapp University for the creation of a simple marketplace dapp, which has been configured to work on the Harmony 1 testnet blockchain. The marketplace dapp allows individuals to buy and sell items on the blockchain. It consists of a single smart contract and a dapp to interact with it. The demo script will deploy the smart contract onto the Harmony 1 testnet when you follow the instructions in the README on the GitHub. Now, before we jump in and start the dapp, let's have a quick look at the source code structure and the underlying smart contracts. The marketplace repo is a mono repo with both the smart contract and the dapp stored in the same structure, with all of which are stored within the source directory. Source components directory hold the React.js code to interact with the marketplace smart contract. app.js holds the logic to interact with the blockchain. So what you will see is you'll see abilities to load the Web3 connection by talking to Windows.Ethereum, interact with MetaMask, etc., or load blockchain data, which will actually go to the smart contract and load the information. It also contains main.js, which holds the rendering logic for the page. So what you see on the web page, the information that comes back from the smart contracts, etc. Source/contracts contains the smart contract logic. So we have a simple smart contract representing the product we want to buy, and data structures that represent the storage of all the available products. So you see the data structure contains an ID, name, price, the current owner of the product, and whether or not it was purchased. It has a mapping, which holds the product versus the ID of the product, and it holds the current product count, and a name of the marketplace. There's functions that exist to create a product, as well as to purchase a product that's on sale. So you have a create product. There's a few tests, and it will emit some events. So in this case, it will emit a product created event, and there's a purchase product, which will emit a product purchased event. So the purchase product will take an ID, and it will accept some 1 tokens to allow people to buy that particular product. So in this case, for purchase product, there is one interesting logic whereby the seller cannot be the message sender. So all of these are actually business logic to ensure that the purchase product has the valid arguments. These are a set of rules that make sure that the purchase is valid, including the buyer is not the same as the seller. So we will test some of these rules once the app is actually started. So the product map and the number of products and the name of the marketplace are all public variables. So public variables allow anyone to read the contents but can't change it. And it just makes the code more succinct. The compiler will generate the functions to be able to access these public variables. A challenge that you might want to consider is to try and change the mapping to an array. So now, instead of having product count and a mapping, you can just reduce that to just a dynamic array of products. Then that will just save an additional variable cost for storage, and it'll make the code a little bit more readable. Another challenge you might want to look at is to make the require return more meaningful error messages. This is 0.5.0, which doesn't have the strings for returning any errors that happen during require. So upgrading the smart contract version, Solidity version, and then adding some error messages to the require so that the UI can pick those up and display it to the user. There are some prerequisites before we can compile, build, run, and have fun. So for the environment, you will need Truffle, Node, and NPM. And it should be accessible in the command line. So in my case, my Truffle version is 5.3.10. My Node version is 15.14.0, and my NPM version is 7.7.6. Getting the latest one should work. There's no fancy code in here that requires a specific version. So for interacting with the smart contract and the blockchain, you'll need a few accounts with some testnet tokens. So if you follow the instructions on the GitHub page, it will guide you to being able to get those test tokens. So let's try to build and run the marketplace now. Now, before we can build the smart contracts and deploy them to the testnet, you will need to configure the truffle config.js. So you need to configure the private key. And you can get the private key by going to MetaMask, accounts, details, and then actually exporting the private keys. So I'll just do a quick example of how you do that. I'm not going to show you the private key, obviously. So you go to MetaMask, you go to account details, and then you go export private key. Enter your password and MetaMask will show you the private key. Copy the result of that private key into the truffle.js, and then you may begin the next step. For tutorials such as these, the best practice is to create a random public private key pair that is only used for testing. You paste that private key into truffle.config.js and then save it. So to begin, let's first install all the dependencies. So we just run npm install, and it will just take all the dependencies throughout the different environments and put them into our one. Next, what we'll do is we do a truffle compile, which will take all the smart contracts in source/contracts and compile them. See, it's successfully compiled and saved to source/ABIs. Finally, what we're going to do is we're going to migrate this onto the Ethereum testnet. So as you can see, I'm using the testnet configuration in truffle config.js, and I'm doing a reset, which basically is just flushing the existing scripts that I might have deployed and deploying a fresh install. You don't need to do the reset, but I do that because otherwise the demo doesn't spit out the necessary outputs. So this will take a moment. Obviously, I will just cut the video and make it faster. All right, so we have deployed. It's taken 0.0073 ETH. That's actually just one. So it's Ethereum compatible. So that's why we're reusing Truffle. We do output ETH. So if you copy the contract address and then go to explorer.pops.1, this is the testnet blockchain explorer. Paste the address in and you can see some events. So it's actually been deployed into the blockchain. Nothing's happening at the moment because it's just been deployed, but you can see when it's being deployed, the transaction hatch. You can see a bit of information about the contract itself. And we can always refer back to this once we start interacting with the blockchain. Now, the next thing we need to do is to actually run the dapp itself. So if we go back to our terminal, we go npm start, and that'll pop up a dapp inside localhost 3000. So you can see the dapp University blockchain marketplace. So we'll add a product quickly. We just call it product 1 and it will cost 1 ETH to buy. We add that product in, it will pop up a message in MetaMask telling us, hey, this smart contract, this dapp is asking you to sign this transaction, pay some transaction fees to list a product on the dapp University marketplace. So we click confirm and then we wait a bit while that particular transaction is being mined. If we go back to here, we should be able to see something happening. Oh wait, there you go. So what's happening is we are calling from this particular direct address to this address. We're not doing anything here, and we have a particular hash. If we go back to here and then we refresh the page, we will see the product appear, and it's asking for 1 ETH. And the owner is this particular guy. Now if I want to buy that, all I do is click the buy button, and it's being rejected because the contract itself is being reverted because I am the owner of that particular product. So if I reject that, press refresh, and then I switch accounts here. Then I try to buy it. Maybe I'll refresh again. Then I'll try and buy that product. Yep, you can see it goes through. Click the confirm button, and I just wait until that particular transaction gets mined. And if we refresh the contract on the Explorer, you you can actually see there's a transfer function that happens, a transfer between this address, we're transferring 1 because the owner of that particular product has been paid by the smart contract. So smart contract itself is acting like some form of escrow. So now if we refresh it, we should see an updated owner, and now you can't buy it as well. So we have the owner has been updated. He paid 1F for this particular product called product 1. If we look at the balances, you can see that 1 and a bit F has been transferred out of account 1. And if we go to totally not my real account, you see that almost 1 has been transferred to the owner of that address. So you can see there are some challenges to this application itself. It doesn't refresh properly, so you do have to press that refresh button. It doesn't capture error messages because errors that come back is just a revert. So there are a few improvements that you can also consider. But there you go. That's the blockchain marketplace app. I hope you guys enjoyed it.